Hello, I'm Kaz. This is my second video that I am going to be doing on some math stuff for you guys stuck at home with kids that are looking to understand things a little bit better to help them out maybe, and maybe even just learn a thing or two yourself. Yep, normally I'm an econ guy. I'm going to hopefully be putting out some more economics videos in the future on especially some of the stuff surrounding the pandemic right now and how we look at that in economics. But yeah, right now we're talking about math. Like I said, this is my second video. The first one was very basic on multiplication, things like that. We're moving up to just a little bit harder maybe. We're getting into fractions. That's what this video is going to be about. So there's a lot of people out there. There's a lot of adults out there that struggle with fractions, which is perfectly fine. That's not your fault. That's something that we don't always deal with on a day-to-day basis. So you can get by fine without knowing tons about fractions. But if you do want to know more, and especially when your kids are going to want to know more, and we're just maybe hitting that point where you're not as good at it, I want to just explain you how things work real quick, and hopefully it'll give you some insight, give you again a different way to think about fractions that'll hopefully help you out. And as a bonus at the end, we're going to teach you to calculate a 20% tip. I know that's the one place where sort of some division and multiplication can be helpful in your everyday life, and some people struggle with that. So I just want to give you my secret. A lot of people use this, so if you're watching this, you very well might use the same strategy as me. I just want to, yep, that's your little bonus at the end, a little carrot. So, yep, come on, let's go head to the board. We'll check it out, and yep, we'll hopefully learn something today. All right, we made it to the board. It took me like 2 days to walk from my chair to the board, and I changed shirts in the meantime, but here we go. We're just starting with the basic rules. I'm going to try and make this fast for you guys. So these are just a few real simple tricks for fractions that you're going to need in a lot of cases. So anything over 1 is whatever it is over 1. So anything over 1 is just itself. It can be, if this was 7 over 1, then it's 7. If it's 1/16 over 1, then it's 1/16. So yep, anything over 1 is itself. 0 over anything is 0. That one is pretty self-explanatory. If you have 0 halves or 0 quarters, you still have 0. Anything over 0 is undefined. That gets into a little bit of math stuff, into exactly what that means. It's basically bad, and you should never divide by 0 because it doesn't, and for most of you, it just doesn't mean anything, and it doesn't really make sense to do. So, yep, that's something you should, if you end up with a 0 on the bottom, you probably did something wrong. And anything over itself is 1. So that is going to be a valuable tool that we'll actually use later. This one specifically. Anything over itself is 1. So those can be fractions too. A half over a half is 1. A 16th over a 16th is 1. So yep, that's going to be important for us later. So we're actually starting with multiplication and division because, believe it or not, those are actually easier than addition usually with fractions. There's a lot less to worry about. So multiplication, the real trick I want you to think of here is the fact that this this times sign, I want you to think of that as of. So 3/8 times 2/3 is really saying 3/8 of 2/3. And so if you, that's why a half times a half is a quarter, but you would just say half of a half is a quarter, which makes sense. If you were playing a football game or something, you'd say, okay, what's the halfway point between starting the game and halftime? And you'd be like, oh, the end of the first quarter, right? Half of a half is a quarter. So, yep, that's going to be important. The real easy part for this, multiplication, is basically the easiest one. All you're doing is you are going straight across. So all you have to do is, let's draw our fraction we're going to end with there. We're just going to multiply 3 by 2 and get 6 up here, and 8 by 3 and get 24 down here. We're going to go over reducing fractions later. So in this case, those are both even numbers. You can make this into a simpler form, basically. But yeah, that's all that there is to it. It's really simple. You just multiply straight across. So whatever these fractions are, you do that. If you have a whole number multiplied by a fraction, if this was, let's say that this was 2. So what you do here, the easy way to see this is just, like I said, anything over 1 is itself. So just put this over 1, and then you haven't changed it, and you have a fraction to deal with, and then you can multiply across. So you'd end up with 4/3 here, because you do 4 and you do 3. So real simple. The other way you could think about it is just when you have a whole number, it's going to the top. So it's just multiplying by the top and you're keeping the bottom. So yep, that ends up as 4/3. So real simple there. What I'd like to look at, I guess I don't need to erase anything. What I'd like to look at is what this looks like essentially. If this were the whole here, let's say, like I said, we're calling this of, we want half of a third. What you're doing, and it doesn't matter which way you do it, half of a third or a third of a half, either way you say it. So what we're doing actually here is that's our half, and we want, let's say we're dealing with this bottom half here. We want a third of that, so we're going to divide that up into 3 chunks. And we want this chunk then. And since there's an equal 3 invisible parts up here, we now have 6 total parts, and we just want 1 of those. So that's what you're doing when you multiply a fraction. So let's move straight on to division. Division. Basically, the trick is using what we call a reciprocal, which is turning the fraction upside down. So this 1/3 becomes 3/1. You know, a 1/4, the reciprocal of 1/4 is 4, but that'd be 4/1. So you're just flipping it up. The basic idea here is you want to flip this one on the bottom and just make it a multiplication up here. So dividing by a fraction is the same as multiplying by its reciprocal. So this is equal to 1/4 times 3/1. So if you can see, I just took this 1/3, I flipped it upside down, brought it up to the top, and just made this a multiplication. So then we can just multiply across, and real easy in this case. So yep, that's basically the trick there. The other way you can visualize like this same problem. This is the way I mainly would suggest you look at it. Is you're just taking the bottom one, you're going to flip it upside down and move it to the top. That's yeah, the basic way that I would understand it. But another way that you can look at this would be so you can look at it this way, and because these are equivalent statements, like I said, no matter what you have here, if this were like a whole number, you're just moving it to the top. Yeah, these are equivalent statements to the last one, to having the 1/4 up here. So anything you're going to times by a fraction, you can just move to the top there. You can just sort of crunch this thing down. Sorry, I guess this isn't the best way to see it. If we had this is what we started with. We can actually just crunch this top one down, and we get the same result. The same thing happens. So what I mean by that is we compress this line in the 1/4 all the way down to this. The fourth gets pressed down into the top of this fraction. So what this ends up with is 1/4, and then we'd actually still end up using our other trick. We'd flip this around, bring it to the top, and this would just be 1 times the reciprocal of that, which is 3/4, which is 3/4, which is the same thing we got before. So there's a lot of ways to like look at division, and division can look maybe a little bit different sometimes. But the basic principle is take that bottom one, what we call the denominator. I didn't mention that, but numerator is the top one, denominator is the bottom one. We're just going to flip that, and we're going to bring it to the top and make it a multiplication. So that is your basic rule there, real simple. So now I'm going to reset the board real quick, and we'll talk about addition and reducing fractions, because those get into just a little bit more complex stuff. So let's check that out. All right, we reset the board, and we're going to talk about reducing fractions and addition. There's a lot of things that you'll have to mess with at addition to kind of get it right. It might take a little bit of practice, and sometimes you can end up with some really like big numbers on top and bottom and stuff if you're working with larger fractions that just make it look confusing, but it's the same thing every time. You just have to, sometimes you'll have to write it out a little bit to make sure you got your numbers straight, because you can get to big numbers. So let's start with reducing fractions. So this is what we want to do, is we just want to make these fractions into the simplest form. So basically this is for making them look pretty, and it's also for our own understanding, so that later on we're not working with all these numbers that look weird. If we have 2 fractions that are actually the same, we can realize that they're the same even if they look a little bit different. And so that's the purpose of this. So reduction, anyone who's worked with fractions can look at that and say, okay, that's a third, and it's pretty easy to see. But the reason that works, the reason that we can reduce, is that the simplest way to see it is just multiply by a third to the top and bottom, and so both of these have a multiple of 3 in them. This is 1 times 3. That's 3 times 3, right? 9 is 3 times 3, and so. Yep, if we sort of take out that that multiple of 3, then we just shrink them down a little bit. Since this is a third on the top and this is a third on the bottom, we are multiplying essentially by 1, because same thing top and bottom, it's 1. So that is why we can do this, and we haven't changed the number at all, and that's the important thing, is we didn't make any change to it. So that is going to be 3 times 1/3 is 1, and 9 times 1/3 is 3, 1/3. So in this case, just to give you another example, this is going to be a half over a half. This is something you can easily pick out, because anytime you have an even number, top and bottom, they're both going to have 2 in there, factor 2 in them. And you can, the same thing with 5s. 5s are a pretty easy one to pick out. So if you have a number that ends in 5 or 0, both top and bottom, then you almost certainly got a factor of 5 in there, and you should, yeah, divide by 5 to see what happens. But yep, in this case, 4 times a half, 16 times a half, that gives us 2 over 8. And then we realize that this 2 over 8 still has a factor of 2 in it, because both of those are even. So we do it again. And that gets us all the way down to 1/4. If you see that this is 4 times 1 and this is 4 times 4, then you can just pull a factor of 4 directly out of there, and just do times 1/4 over 1/4. But that's just something that you have to see. If they're both even, if you have a bunch of weird numbers in here and it's 128 over 164 or something, you might not know exactly what that's going to end up reducing to. So you can just keep doing 2's over and over again until you can't do it anymore. And that's the easiest way to go about that, to make sure you don't miss anything. So here we go. We're going to move over to addition now. The trick with addition is our bases, our denominators. So if we have mismatched denominators, I guess I should start with a real easy one. If we have the same base, then it's no problem. If if we were working in dollars here, this would be 25 cents. That'd be 25 cents. You get 50 cents, which is half a dollar, right? So what this actually does is you're just keeping your bottom number, and you're just adding up across the top. So this is going to be 2 over 4, which if we reduce is obviously half. So yep, once you have the same base, you're just adding up the tops, keeping the base. That is your strategy. But it becomes complex when we don't have the same base. So I want to draw you a little picture of exactly what's going on here. So these are, let's say these are like 1, one each, one full thing. So let's divide this one up into quarters, divide this one up into thirds. So what we're doing is we have 3/4, that's plus 2/3, and this is tricky because these are not quite the same height. You see that this doesn't fit into a nice category in how many fourths it is or anything like that. So what we need to do is we need to break these up into even smaller chunks, so that each chunk is the same size, and then we can say how many chunks are there between them. So we have the same size chunks over here and the same size chunks over here. We can figure out how many we have, and go from there. So what we want to do that is figure out exactly how small chunks we need. And the easiest way to do that, sometimes there is like shortcut, a simpler way that looks nicer, but the foolproof way that's always going to work is you multiply the denominators, the bases here, and that's going to give you the size of the thing. So in this case, 4 times 3 is 12. That means our sizes need to be 1/12, so twelfths. And to get this into twelfths, right now we have this in fourths, what we need to actually do is break this up into 3, right? If we have 3 there, that makes 6, that'd make 9, that'd make 12, and we'd have 12 total pieces. And so each one would be a 12th. In this case, we got 3 pieces. We need to divide each of these up into 4 because we need to have 12 total pieces for this full one. And we'd have 4 there, we'd have 8, and then we'd have 12. So yep, we would have the same size. So yep, multiplying those bottoms are going to tell us exactly what size we need those chunks. Then we need to figure out how many chunks we have. So the trick to this, here we go, is again, we're going to multiply each of these. What we're going to do essentially is multiply each of these numbers by 1. But in order to do that and get a 12 on the bottom, because we know we need a 12 on the bottom, so we're working in 12ths and we can add up across. In order to get this number to be 12, we need to multiply this by something over itself to get you base 12. We know that's going to be 3 because that's how we came up with that number, was multiplying it over there. And so since we're doing 3 to the bottom, we're going to do 3 to the top. And so what we're going to do is 3 over 4 times, I'm just going to put these parentheses here, so this is becoming this just by multiplying by 1, by 3 over 3, and then to make this into 12ths, we know that we need to multiply by 4. So we're going to do plus 2/3 times 4 over 4. Bam. And then we can just figure that out. This one ends up being, if I can write, 9 over 12, right, just by 3 times 3. And then this one ends up being 8 over 12. And then we can actually add up right across the top. We get 17 over 12, which some teachers will want you to make, they'll want you to subtract 12 out of there, make this 1 and 5/12ths. In general, in most like later on math classes, we're just going to leave this like this. So yep, that's what you're doing. That's the long and short of it. The trick is the fact that this looks kind of ugly and kind of intimidating. It's really simple. I'm going to do it again, and this time I won't show quite as much work, and I'll just do it more the way you think about it. So we're going to figure out, okay, we need to make these bases the same. We're going to multiply them together so we can figure out size. That is going to be 4 times 3 is 12, so we need 12 on the bottom. Since to make this 12, we had to multiply it by 3. We also need to multiply that one by 3. So we're just going to bring the 3 over here and up there, and then we're going to bring the 4 up there and down there. So that gives us 3 times 3 is 9. 3 times 4 is 12. Then 4 times 2 is 8. And 4 times 3 is 12. And so we've got the same base. We can add up normally, and we've got 17 over 12. So that is, yep, the long and short of how addition works. Subtraction is exactly the same. You just would sub out the subtraction sign there. And so you would, in this case, if this were minus, then we'd do that exact same thing to get our 12s on the bottom, because all we did to get from this step to this step before we did the calculation was just multiply the top and bottom of each number by something that was 1. So we just do minus there. Now we're doing 9 minus 8, and that would just give us 1/12. So that is the basics of fractions. I'm probably missing some stuff, but that hopefully will give you the tools to be able to work on them. If I can answer any more questions, then definitely let me know. And there will be, another video or 2 coming soon. I'll be transitioning back to economics before long, but yep, if you have any more questions on math or economics in the meantime, let me know, and I will continue to make videos for you. Thanks.